Let's talk about the invisible force transforming our world: high-end computer chips. These marvels of engineering are so small you can barely see them, yet they're at the heart of nearly every modern device. Without them, our digital lives would come to a standstill. These tiny silicon brains are everywhere, inside your phone, your car, and the networks connecting us all. They quietly process billions of instructions every second, making our lives faster, smarter, and more connected than ever before. They're the engines of innovation, powering everything from AI to self-driving cars. From the apps you use daily to the futuristic robots in research labs, chips are the foundation of progress. The country that masters these chips holds the keys to the future. It's not just about technology, it's about economic power, global influence, and even national security. Now, the next frontier is artificial intelligence. No longer science fiction, but part of daily life. AI is in your voice assistants, your smart home, and even the way you shop or travel. AI needs immense computing power, and that's where these advanced chips come in. The smarter the chip, the more powerful the AI, enabling breakthroughs in medicine, science, and communication. The race to build the best AI is really a race to build the best chips. Whoever leads in chip technology will shape the next era of innovation and control the digital landscape. The US leads in chip design and production, but China is determined to catch up and even surpass. This rivalry is reshaping global alliances and supply chains. For China, this isn't just about economics, it's about national security and shaping the future. Chips are seen as the backbone of military strength, economic growth, and technological independence. So, how close is China to catching up? This is a story of ambition, obstacles, and global impact. The outcome will affect everything from the gadgets in your pocket to the balance of power worldwide. We'll break down where China is succeeding, where it's struggling, and why this matters to you. Let's dive in and explore the high-stakes world of the tiny giants powering our future. China's chip journey splits into two crucial paths: design and manufacturing. Both are essential, but each comes with its own unique set of challenges and opportunities. In the realm of design, Chinese companies like Huawei have made remarkable progress, developing blueprints for advanced chips that can stand toe-to-toe with those from US tech giants. Their engineers are pushing boundaries, innovating at a pace that has surprised many in the global tech community. Imagine having a team of world-class architects. They can envision and draw up plans for the most cutting-edge skyscrapers, filled with futuristic features and bold designs. Huawei's chip designs, including their ambitious 3-nanometer chips, are now nearly on par with the best offerings from industry leaders like NVIDIA and Apple. This is a testament to China's growing expertise in chip architecture and innovation. But when it comes to actually building these chips, the story changes dramatically. The leap from design to manufacturing is enormous. Manufacturing high-end chips is one of the most complex feats in modern engineering, demanding atomic-level precision, flawless cleanroom environments, and highly specialized equipment. Here, China still lags far behind the world's top manufacturers. The gap is not just about machines, but also about decades of accumulated know-how and experience. They have the blueprints, but lack the advanced tools, materials, and deep expertise needed to mass-produce the most sophisticated chips at scale. Even with brilliant designs, China can't manufacture at scale without access to critical technology, much of which is tightly controlled by the US and its allies through export restrictions and embargoes. This widening gap between design and manufacturing is the heart of China's semiconductor challenge, and it's a problem that can't be solved overnight. It shapes their national strategy, fuels ongoing struggles, and influences the global race for technological supremacy. Every move is watched closely by competitors and allies alike. Until China can close this critical gap, its ambitions to lead in the semiconductor industry will remain just out of reach, no matter how advanced their designs become. The world is watching, waiting to see if China can bridge this divide and what it will mean for the future of global technology. The secret to building advanced chips? Lithography. Imagine printing a city map onto a grain of sand. That's the precision needed. The most advanced chips require extreme ultraviolet, EUV lithography machines, made only by ASML in the Netherlands. US restrictions prevent China from buying these machines. Without EUV, China can't mass-produce the latest chips. China is racing to develop its own EUV technology, But it's years, maybe a decade, behind. For now, they rely on older deep ultraviolet (DUV) machines, which can't match the performance needed for cutting-edge AI. It's like racing Formula One with a family sedan. This lithography bottleneck is China's biggest obstacle. Until they solve it, they'll remain stuck, able to design the future, but not build it. The world's most advanced chips remain just out of reach. In the world of AI chips, two names stand out above the rest: NVIDIA and Huawei. These tech giants are at the heart of a global race, each pushing the boundaries of what's possible in artificial intelligence hardware. NVIDIA is the undisputed global leader, with cutting-edge chips like the GB300, setting the gold standard for AI performance. Their relentless innovation has made them a household name in the tech industry. Decades of experience, a robust software ecosystem, and deep partnerships with major tech companies make NVIDIA the go-to choice for anyone building advanced AI systems. On the other side, Huawei, despite facing strict US sanctions, has engineered its own competitive AI chips, the Ascend series, demonstrating remarkable resilience and innovation. On paper, Huawei's latest chips can rival NVIDIA's designs in many technical aspects, showing just how far China's semiconductor industry has come. But here's the catch: NVIDIA's chips are manufactured using the world's most advanced semiconductor processes, giving them a significant edge in speed and efficiency. Meanwhile, Huawei is limited to older manufacturing technology, which restricts the performance ceiling of their chips, no matter how brilliant the design. This means that, although Huawei's chips are impressively designed, they simply can't match NVIDIA's power and efficiency in real-world applications. It's a bit like having a world-class recipe but only basic ingredients to cook with. The result is good, but not quite as extraordinary as it could be. Still, Huawei's achievements prove the depth of China's engineering talent and their determination to close the gap with global leaders. Yet, the limitations in manufacturing keep Huawei a step behind, highlighting the importance of not just design, but also production capability. NVIDIA's edge isn't just in chip design, it's their access to a global supply chain, advanced manufacturing, and international markets that keeps them ahead. The rivalry between Huawei and NVIDIA is more than a business competition. It mirrors the larger US-China tech struggle, with both nations vying for technological supremacy. Ultimately, this isn't just about two companies. It's about who will shape the future of technology itself. The race is on, and the world is watching. If China can't match US chip power, they compensate with scale. Instead of one superchip, they use many less powerful chips working together. It's a brute force approach, but it works. Imagine moving a mountain with a fleet of small trucks instead of one giant one. China builds massive data centers packed with domestic chips, achieving similar total output. The government drives this strategy, funding huge server farms and creating a captive market for Chinese hardware. China's vast digital economy generates enormous data, fueling this approach. By deploying thousands of chips, they can rival NVIDIA's performance at the system level. It's a different path to the same goal: AI dominance. Scale is China's equalizer. China's more is more strategy comes with a cost: energy. Running thousands of less efficient chips uses far more electricity than a few advanced ones. This means higher energy bills and more strain on the power grid. But China's massive investment in energy infrastructure, solar, wind, coal, and nuclear, makes this possible. They leverage their energy strength to offset chip inefficiency. The competition isn't just about chips, it's about the whole system: data centers, power, and coordination. China's holistic approach is helping them catch up faster than expected. The US may have better chips, but China is building a more integrated machine. The race is about more than speed. It's about building the entire racing league. System-level thinking is China's secret weapon. US government policy is a major force in this race. Strict export controls block China from acquiring advanced chip technology, especially EUV machines. Sanctions target companies like Huawei, cutting them off from key software and manufacturing partners. The goal: keep America ahead by slowing China down. But these restrictions have sparked a massive push for self-sufficiency in China. The government is pouring billions into domestic chip development, making tech independence a top priority. Sanctions have forced China to innovate, reverse engineer, and build its own alternatives. The result: a surge in national unity and urgency. US controls have slowed China in the short term, but fueled their long-term drive. The race is now defined by this dynamic: roadblocks versus relentless determination. The outcome will shape the future of global technology. The stakes couldn't be higher. Politics is the wild card in this tech race. A change in US leadership could rewrite the rules overnight. New administrations might relax or tighten export controls, shifting the balance. There's talk of deals, like allowing exports of slightly older AI chips to China, or trading rare earth minerals for semiconductor tech. Such moves could accelerate China's progress or make their path even harder. The future of this race isn't just decided in labs, it's shaped in Washington and Beijing. Policy shifts create huge uncertainty. If restrictions ease, China could leap forward. If they tighten, China faces even steeper challenges. The next chapter depends as much on politics as on technology. The world is watching for the next move. Everything could change in an instant. So, can China catch up to the US in high-end chips by 2030? The answer? It's complicated. The US and allies have a huge head start in manufacturing, expertise, and supply chains. China is making rapid progress, but the lithography bottleneck is a massive hurdle. Catching up to a moving target is tough. The US isn't standing still. Still, China's system-level strategy, using scale and integration, could make the performance gap less meaningful in real-world AI. They may not have the best chip, but they could build an AI ecosystem that competes globally. The race is far from over. China's investment and determination mean the gap will keep narrowing. The US lead is real, but not guaranteed. The next 5 years will decide who leads the AI age. The world is watching.